All right, let's begin. This is the first stream that we'll be doing live from Decentral Lab. Decentral Lab is essentially focused on research and development and mining ASIC repairs. So today it will be the first live we'll be doing regarding the mining ASIC repairs. We'll start by taking off some ASIC chip there because I've already used all my supplies. So it's going to be pretty basic stuff to start with. Um, we already have some tutorials on the matter on our YouTube channel. So as probably some of you know, we've been focusing on creating a lot of content to try to educate the community, either it be directly towards mining, either it be towards Bitcoin, Lightning Network. So we try to cover a lot of concepts. Obviously, our specialty is towards mining. So we've been miners since 2016. We have a mining facility that's used to offer hosting to individuals of any size. And lately, we've been doing a lot of repairs, either for big public companies or for individuals. So we have a lot still of S17 in queue for repair and upgrades. So we'll be doing some of that today. Let's start with tinning some chips. Just know that we're a Quebec company, so it's possible to have some comments that are written in French. I'll be answering those comments in French. I'll mostly be speaking in English, but if there's a lot of comments in French, I might be speaking French in this stream as well. It's going to be probably somewhat bilingual streams. I'm more fluent in French, anyways, but since there's a bigger network of people that we can reach through the English language, obviously, I'll be defaulting on that language for now. So let me just go grab some gloves, make sure we have everything to get this started, and let's do this. Again, we're starting with some really basic stuff there, so just properly tinning our new chips, and we'll be able to fix some boards with that. You need to have a clean plate, so we'll just spray some alcohol there. And let me grab some paper there. All right. Perfect. Yep. Oh, there we go. And here you go. So pretty basic stuff, as long as you don't fat finger it. There we go. And then we'll be using some solder paste. I'm using this one here. T4 is the grain size, and this mix has been doing well. It's perfect for the temperatures that S17s and T17s, all that 17 series is running on. Just grab here, this here, and we'll spread on the chips. So again, very essential stuff will be, so this step is what we call tinning the chips. This is the first step before repairs. Here. I like to use those multimeter extensions there to push the chips away as they tend to stick to the plate there. Next step is pretty simple. We simply heat the solder paste. We put some more wine force there. So obviously, if you're launching yourself into ASIC repairs, especially for 17 series, we do have a lot of those inventory, chips, flux, solder paste, everything that you might need to do repairs. We have that on our shop, so you can go ahead and navigate there. Decentral.tech, d-central, central dot tech, tech. And this one, we can see some of the chips aren't covered, so we'll get back to this one. So those are BM1397 chips. Most of them are AG. I have some AI as well in the lot. So BM1397 AG and BM1397 AI. Both chips available on our shop. So we try to avoid the chips falling on the solder paste. Fortunately, the carpet is pretty clean now, so there's no dust or any other residues that could go into the soldering, but we try to avoid that. Now, this chip has also some missing legs, but this aside, this one might have a bit much of solder paste, but I think, yeah, this one should do it. All right. This one is perfect. Mm. Still some solder there. Try to clean this there. That should do. Can apply some more solder paste. Make sure we have good enough quantity. This one is probably gonna miss some. We'll still try it. Side. Good. All right. So let's start with this stash and analyze our first hashboard. So I'll go and grab one hashboard that's been waiting for repairs and upgrades. All right. So we have S17 board here. We removed all the heatsink on this board for some obvious reasons. As you can see, a lot of the chips are delaminated. So what are delaminated chips? Well, essentially, they are those darkened chips where you can have some kind of mirror effect. Those chips, the big issue is actually that you can't resolder the heatsinks on top of them. So a new chip is going to look like this one here. This is some copper. This copper film here, it tarnishes with time and it oxidizes. And the tin that's grabbing on top of the copper is forced to go sideways on the chip. So this is why a lot of people noticed when they open their machines or when they fix ASICs, they're going to notice some solder balls that go on top of the chips, and most of the time they're going to create shorts. Those solder balls are essentially the tin that's being pushed away from the heatsink and the top of the chip, and they fall onto the chip legs or onto the sides. So as you can see, this board had a lot of delaminated chips. So one of the best solutions to fix that issue is essentially to solder some nuts here, like this. So we'll solder this on the ground pads of the hashboard here, and we'll stick heatsinks on top of the hashboard. Let me go grab a heatsink just to show you. So this is a heatsink, all-in-one heatsink solution that you'll be using to put on top of your hashboard, like that. And this is going to obviously have a much better thermal conductivity than the standalone heatsinks that most of the time will start to have issues distributing the heat. When you have chips like this one, the heatsink is still going to hold, and you won't be able to notice that it's getting delaminated under it. But if you look at the chip map in a firmware like, let's say, Vinish, you'll be seeing that this chip is probably going to have a weaker performance than its neighbors here. And the reason why is because the thermal conductivity between the chip and the heatsink is starting to decrease. And since your machine is going to aim to keep a certain safe temperature for the chips, it's going to decrease the actual frequency of that chip, so it protects it from overheating. So this is essentially decreasing your performance on your machine, and in some cases is going to lead to a complete delaminated chip until the heatsink finally falls off. And the thing that might happen when your heatsink falls is that they can touch another domain. So you have these rows there, they are domains. And if two heatsinks from a different domain touches, it might create a short, and those shorts sometimes they can burn hash boards. We've seen a lot of hash boards that are completely burnt by some shorts caused while the machine was hashing. So these are issues that you definitely want to look into. And using the all-in-one heatsink solution, it avoids heatsinks essentially falling off during transport. It avoids delamination to cause more issues, because now even though there might be some, even though that chip or that chip would keep on delaminating, it's not going to create as many issues as it would if it was standalone heatsinks. So let's go ahead and do a diagnosing of what's the issue with this hashboard. So first, I'll plug in my ASIC tester. I'm using the ARC tester from ASIC Repair Center. And let's plug our variable power supply there. So I'm setting my board at 21 volt. The reason why we set it at 21 volt for the chip detection is essentially because in the unit, the power supply is starting at 21 volt to discover the chips on the hashboard. After it starts at 21 volts, it's going to start decreasing to the values that are set in the EEPROM of this hashboard. So we have our multimeter here on the screen. Let me just go ahead and power that. We may have to open the light there, yes. And do we have a good view? That looks awesome. So let's start the test. You should be seeing on the right middle screen, there's the chip map of this hashboard, and we should start seeing something happening on the screen. Here you go. So we can see that the tester is able to reach the 44th chip, but something's preventing the signal for passing through the latest domain. So let's go and try to see what's causing this issue. We start by measuring DC voltage test points. So we'll ground ourselves on the top of the chip. The top of the chip is a ground for this domain, and we can go ahead and measure some touch points that we have on this board. So if we go ahead and, sorry about that, hit this here, so what I'm looking at right now, I don't know if you can see it properly. The touch points are a bit small, and I might have to get a microscope to share this with better resolution. But I'm looking at the clock touch point between the 44th chip and the 45 chip. And what we're seeing here, when I stay stable on the touch point, is we have a measurement of about 0.8, so 0.85 now that the board is eating up a bit. So let me stop the test for a sec. So we have the clock that's in between the values that we're looking for. We're looking for values of 0.7 and 0.9. So in this case, the clock looks like, based on the DC voltage measurement, it looks like the clock is passing by. So the issue might be with the 45 chip. It might be with the domain. We'll go and analyze that. Just before we proceed, I'll take my fan here, put under the hashboard, because when all the heatsinks are removed from the hashboards like that, before an upgrade, those boards, they tend to get out really, really quick. And that's what just happened, and that's why the measurement of our values started to fluctuate a bit. So let's start that test over again, and we'll look at the next chip to see if we have any hint on the next issue. Alright, so here our measurement, definitely not an expected measurement. Let me put some light here so you can see. So we're having 1 volt. I'm expecting between 0.7 and 0.9 volt. So definitely there's an issue there. It might be the chip, but it might be related to the domain as well. So let's just see. But quick like that, the next chip has a good value. This chip is a bit high actually, so we might have to get back to this, and we can skip the last one. So what I'll do is I'll start with changing the 45 chip, and we'll see if that changes anything. So we use some flux, put some flux on the top and the bottom of our chip, grab tweezers, our hair gun, and you heat until the solder is is melting, you'll be able to remove the older chip. Can keep on hitting a bit on the pad when we remove the chip. This allows for there's going to be some solder spots that might create some denivelation on the pad. So by hitting it, the denivelation kind of normalize, and if need be, depending on the tin color, the tin quality, by how you look at it, and you might have to retin, you might have to clean with the copper wick. It is a best practice to do it, but most of the times you can avoid that step and just simply use a Q-tip, alcohol, put some flux, and apply your new chip. So from the look of it, this should be good for just a simple alcohol cleanup. So let me, again, cool that board. Also have a fan here that I can use to go faster. Want to make sure that when I come and clean that area, the components around the chip that I just removed aren't going to move. So this is why we want to make sure that everything is well cooled down there. Can use some alcohol there. There you go. Clean up. And our pads are super clear. So this shouldn't be causing any issue. Should be all good to install our new chip. Amazing. All right. Let's apply some flux. We can go ahead and apply the flux on the center of the pad. When we apply our chip, it's gonna push the the flux all around. Let me try to zoom on a bit so you can see a bit better. Like this, you should be able to see. We'll optimize the equipment we're using to stream through time. So this is a first, streaming that we're looking, see where we have some hurdles, see what works, what doesn't. If we have any questions, let me go ahead and see if we have something in the chat. Wondering I was wondering when or how those tin balls getting created. So again, those tin balls they get created while the machine is ashing. So there's heat that is coming to the top of the chip, and because of the way the heat transfers, the top of the copper is going to tarnish, and that tarnishment is going to push the tin away because the tin is able to grab on that glass-like top there. So the tin balls, they're going to get pushed away on the chip rails like that, or on the sides. So again, this is happening when it's ashing. Um, there's no like specific moment. It really depends on the model. It depends on the ashing conditions. It depends on the manufacturing condition, because a lot of those 17 series they had manufacturing issues. They're known for those manufacturing issues, unfortunately. But with the Heatsink upgrades, these are, they are very decent and very efficient miners. So I do think they are definitely worth the upgrade. So let me go ahead and install that chip. Do we still see that correctly there? Let me see. No. All right. So you can go ahead and you don't need to be eating while you place your chip. So you can go and follow the guides there. So you have two white lines that are on the side of the chip, and you have your obviously your chip legs that are on top and on the bottom that you want to stay uh, aligned to. And once you're ready, you can start eating. When you install a lot of chips, you get used to it, and you can like just install the chips at the same time of eating. But for the sake of this video now, we'll be doing it with the best practice. So you just place it, eat it after, and you can see the flux is reacting and it's doing its job. You can put a bit of pressure on the top of the chip like that. Make sure that everything fuses well. You look at your top and bottom chip legs, and you make sure that they become shiny. So you should see the tin becoming shiny when it's melting down. It's gonna have a gray silverish color, and once you see it's all normal and standardized, you're gonna be able to stop heating and let it cool down. So let me go ahead and do that just now. What you can also do is you can keep your tweezers on top of the chip for a while just to make sure that while it cools down, everything stays in place, everything is in contact, there's no flux going under the chip, back under the chip. Um, the less, you know, the more direct the contact is through the pads and the chip legs, the better it is for signal and for um, for it to perform well during time. All right. Again, we're gonna want to cool down the dashboard. So we'll bring our fans back there. Let me make sure we can see that. Can come and plug our variable power supply. Obviously, it's not powered on right now. Plug in our hashboard, so our chip map is gonna clear now, like that. And we're gonna be able to start a new test very shortly. We'll just give it a bit more time to cool down. We can always accelerate that process with our handheld fan here. All right, let me see. Going to make sense. So we'll power on our power supply and we'll start the next test. We're still stuck at 44. Let's go and see what's the issue there. Still one. Mm. So this might indicate some problem with the resistance. Let's go and see. So I'll stop my voltage test there and we'll go ahead and measure our resistance. This looks like good values to me. In doubt, you can always compare it to the domain that precedes it, or a working domain. And yes, 33 ohm here. So the resistance doesn't look to be the issue. Well, let me try that again. All right. Our clock. What might be causing issues with our clock there? Alright, we have values there, so our capacitors should be good. This is weird. Let me part down this. Go into diode mode. So we're essentially on target for the diode test there. So the resistance of the chip is good. It's looking like this should be working. If we go to this one here, hmm. So it's not our resistance, it's not our chip, it's not our capacitor. I'm looking for physical damage there. Let me just compare something with another board. Yeah, so it looks like I found some physical damage there. So I'll just go ahead and fix that. So inspecting the dashboard even physically with your eyes is very important. It might be the issue, it might not be, but there's some component missing there, and we have some weird values. Our components in the way of the clock signal are looking great. So in that case, we have to look elsewhere. So I'll remove the component from this dead dashboard there. So this is the component here. I'm not sure you can see it on camera. It's a very small resistance. Let me try to show this on screen. So this is the component I'm going to be removing and installing just here. Not sure if we actually we're not able to see it too much on the screen. Let me try to show it to you here. This is the size of the component we're talking about. So a very small component. Again, it's gonna get better for the streamings when I get a microscope and that we are able to zoom on those kind of procedures there because it's a bit hard to see right now. Let me go ahead and install that resistance. When I install such small components, I usually turn my wind down, so that's why it's making a lot less noise. So it's heating up at the same temperature, um, but with a much lower wind force because we don't want the small components, to fly away. And so yeah, weaker wind helps installing smaller parts. Keep that in mind. Looks like our resistance is well in place. We can remove that here. Go back to cooling down our board, cooling down here. We'll reset our chip map there. Alright. Let's remove the excessive flux there. power on the power supply, and we'll start the test again. All right, there you go. So see, it wasn't a component that was in the way of the clock. It was a component that was under it, a very small component. Let me again show you the component we're talking about. So this little guy right there, this one was missing. So obviously, when you don't know your boards, it's possible that you don't see it. Um, the eyes get trained to to recognize the components and know where there should be and where there shouldn't be any components. So this one I was able to match. Again, when in doubt, you compare it to another board. That's what I did. I don't know those boards essentially all by heart. So sometimes I have to confirm my theory. And what I'm doing right now, so I've just launched an advanced test and I'm calling on the temperature sensors. We should be seeing 4 temperature sensors showing up on the chip map on the screen. There should be one on the 9th, the 12th, the 37, and the 40 chip. So let's go ahead and see if they're coming on the screen. And we have it. So this board, it looks like it's fixed. All we need to do now for the upgrade is to install the nuts. So I'll show you with this board. It's a bit of a longer process, so it's a bit more boring, less exciting than diagnosing and fixing boards. But since this video is called repairing and upgrading boards, we'll be upgrading at least this one board. So I'll show you the step there. Let me remove the multimeter from our screen because we won't be needing that for now. All right. So to install the all-in-one Heatsinks, as I showed you, these are gonna go there. So we're gonna need to have soldered on nuts like this to be able to come and screw onto the board. So let's use some flux and prepare our ground pads. All right, here we have it. So flux. Now let me see. Do I have everything we need there? Oops, sorry about that. All right, so what I'll do, because I don't have so many nuts prepared anyways, I'll show you essentially how we solder one row. The process is essentially copy and paste after that, so you don't really need to see much about that. I can show you an end result just after if you want to see how a finished upgraded board looks like. So we'll do this row there. I know I have some more right here that should already be tinned. So this, and this. So as you can see, we have our nuts there. There's one, whoop, this one is not even tinned. All right, so we have our nuts there. We have one side that's all flat, and the other side you can see that there's the rails for the screws to go in. So what we need to do obviously is have them facing this way. Under it, you're going to want to add some solder paste. Eat that solder paste until it gets thinned, like chips, and we're going to be able to come and install it on the ground pads there. So as you can see, all those there are already tinned. I didn't have too many that are already tinned. I need to make more, so we'll just be doing this one row for this video, and maybe we'll be doing more of that in the future. We can also do time lapse of those. We started to broadcast also, not in live, but we started to add to our channel some time lapse because some repetitive tasks are very nice to see and look at, but maybe a little bit less in live because it's repetitive, so you don't necessarily need uh, to see this at 1x speed, right? Let me go ahead if we have and see if we have more comments in the chat. That's it for now. Oh, let me bring back my 1 speed. There you go. So very simple process. We're heating up the nuts there for it to stick onto the ground pads of the board. So again, a bit like the chip installation, you're gonna want to look at your tin, your surrounding tin. You want to make sure that it's getting to that silverish color, that it's melting down, and that the nut is gonna sit well in place because all the stress from holding the all-in-one heatsink solution is gonna be on these guys. So you want to make sure that they're well soldered onto the dashboard. Otherwise, what's gonna happen is when you screw those hashboards into the nuts are gonna they're gonna crack from the break from the drum pads, and well, that can create damage. It can create damage to the surrounding capacitors. It can create damage by creating a short. um, so you want to make sure that these guys are really well soldered onto the dashboard. And there we have it. We have our silver melting tin color. Onto the next one. And make sure also that they're well sorry, well centered. Um, Again, we have that silverish color there. It's drifting a bit. Let me bring it back. There we have it. On to the next one. And that should be it. So rinse and repeat on all the other rows. You on the Depending on the model, it's not always installed the same way. On the S17, it's gonna be one row, skip, one row, skip, one row, skip, one row, skip, one row, skip. So essentially, you should be seeing more of these like that here, and so on. What I'll do is I'll put this board to cool on my fans there. Let me go grab heatsink that's already been a hashboard that already has its nuts installed on, and also a board that has its heatsink screwed on, and you'll be able to see what the full solution looks like. So I do have to cover a part of the hashboard there because we have, everything that's being in repair or in upgrade here in our shop is being labeled. So some of the boards that I've prepared for the streaming, I removed the label and they're labeled over there, so I know which is to whom. But this hashboard here, it was already labeled, so I don't want to leak any information about this customer. So this is what the hashboard all upgraded is looking like. So the heatsinks under it, they remain like that, but they never have the issues. Those heatsinks, they never fall off. This heatsink here, well, it's all the you would be used to all the standalone heatsinks on top of the chips. They are the all-in-one solution. Much better for immersion, much better for well, even for hair cooling. It's actually first, it won't fail as much. It gives your machine a lot more lifetime. It's also much better for transport. Transport is often a cause of those heat sinks to fail, the stock heat sinks. While those upgraded heat sinks, they last. You could ship them to the other side of the world. They're still gonna hold in place as long as you've soldered your nuts correctly. And let me go and grab that board with nuts installed on, but no heat sinks. This is what a board will look like when you have all your nuts installed on, and no heatsink. So the next step would be, before installing your heatsink, would be to use some thermal paste. What I recommend as a thermal paste is this one here, Ice Diamond by 3M. It's essentially a military grade thermal paste. It's super effective. It is expensive, but it's doing such a great work, and it's well lasting thermal paste when you use it in immersion as well. So definitely a good recommendation. Our top thermal paste is Ice Diamond. We did try a lot of different thermal paste. You can also go on our website in our blog section. There is an article that we've written about that subject. We did a lot of research and development regarding the thermal paste to make sure that our selection was the finest one and the best one for our customers. So you can go ahead and read that blog. It's a very good article. You should be learning a lot about thermal conductivity, as we did. All right, so I got another board here ready for testing, diagnosing, and fixing. Just before we do that, another step that you want to look into before installing your thermal paste and installing your heat sinks is to obviously retest your hashboard. Why do we have to retest the hashboard? It was already fixed. Well, the thing is, when you heat around your components, it's possible that there is some human mistake. It's also possible that a component was very heat sensitive and it blew. So you do have to retest your board each and every time that you do manipulation on top of it. So now that we've installed those four nuts, I don't believe we're going to have damage. But we do want to make sure that it's all good and that it's ready for assembly. You don't want to lose any time assembling that board, putting it in the machine, then finally realizing it's not working. Um, so let's go ahead and do that test. So we have our chip map here that's reset. We have our power supply on. We have all our chips that are being detected, so the signal is going through. Again, what I'll do now is I'll ask as an advanced test for the temperature sensors to give me a reply. Again, we should be seeing four of those on the 9th, the 12th, the 37th, and the 40 chip. So let's go ahead and wait for that to show up. And there we have it. So this board is still good. So what I'll do is later on I'll assign either one of my technician or myself to install those nuts, because this is a repetitive process and it's not too exciting for a live stream. So let's proceed to another repair. So this is a new, well, not a new obviously, but another dashboard that we'll be working on, a new problem that we'll be working on. The all-in-one heatsink solution that I've just presented, we have it on our shop. You can go ahead and buy it. We delivered it obviously with everything you need. So you get the nuts, you get the washers, you get the screws, you get the heatsinks themselves. So all you need then is to buy some thermal paste and repeat the process I just showed you. So let's go ahead. We can see already from visual inspection. Well, so this is interesting. Let me show you here. This hashboard here, I can see it already that somebody tried to fix this chip with glue. Um, So there are some kind of glues that will work to reset heatsinks on the top of your board. I did a lot of testing and a lot of research on that. Um, my my recommendation is to avoid glue on 17 series hashboards. If you do want to go ahead and proceed with that, I recommend you look into the MG Chemical 8330D, I believe. I'll be able to confirm that later on, maybe in the description of the video, or I'll look if I have any tube lying around just to make sure I'm not giving you the wrong product number there. In any case, I do recommend against it. It's really just a temporary solution, and it's really just gonna create a mess long term on your dashboard, and it's just gonna make it that much harder to fix in the future. Um, Sometimes, if you have too much of a quantity, it can also act as isolation instead of uh, transmitting the temperature. So again, the goal here, when you have your tin chips, when you have your copper chips when they're new, what you're going to do is you're going to apply tin like so on top of your chip. This tin is the connection, is the bridge between your copper top and the bottom of the normal heat sinks. Let me show you what a normal heat sink look like. I think I do have, no, I don't have any lying around there. So this is what the heatsink is going to look like. So this guy is sitting there like that. You can see the tin under it. So the tin is going to act, well, first of all, it's going to hold the heatsink on top of the chip, but it's also going to act as a thermal conductor. I believe tin has properties of more than hundreds of W and MK, which is the measurement we're using to measure thermal conductivity. Glues, so the one that I'm talking to you about, the MG Chemical one, is about 13 W and MK. It is enough to transmit the thermal charge from the chip to the heatsink, but the thing is, you really want to have as little of a layer as possible, because the real goal is to actually have the two metals, so the heatsink and the copper, to have as little obstacle as possible on the way. So when you have big layers of glue like this here, it seems to be the case on this here, it might create some issues. So what I might do is actually to use some solution there to clean that that type of chip before we proceed to anything else. Let me just see if I have a right solder top. I'll just use some solution there. This is an acid mix. It's a bit corrosive, so I'll be holding my breath because normally I wear a mask when I'm using this one solution. It's pretty strong. Oh, and let me grab this new flux spot there that I've just opened for the stream. All fresh, all new. A lot of our customers, some machines, they had like all the chips covered in glue. Most of the times, those machines are bought on AliExpress. They come with no warranty. People, they try to, they try to assault their machines. They try to buy cheap machines, and most of the time, that's what they get. They get cheap machines, and then they have to ship it to us. They have to pay for repairs on top of it. So the machines they try to save on, they end up paying more than the market price for the unit because they already have to fix it. and sometimes it's outright scams. I've seen boards covered in silicon. I mean, I've seen silicon on top of the chip, in between the chip and the heatsink. Um, like this is pure thermal isolation. There is no way that this that this works. There are some people that use the, I believe it's Arctic Silver glue as well. Again, this one, like the MG Chemical, it can do, but really I would avoid using any type of glue on the 17 series. I can't stress this enough. You're gonna actually create, on the longer term, you're gonna be creating damage to your board. So either if you have delaminated chips, you change them, or either you do the heatsink upgrade like we're doing. So what I did is with my iron here, I've cleaned all the glue on top of the chip, removed all the glue from the top of the chip. The thing is, it went a bit sideways into the chip legs there. So let me go ahead and try to clean that. Let's remove all the crap from there. No, some boards, the only fix that you have to do is really remove all that crap that's getting stuck. Most of the time, it's not like simple dust. It can be flies going sticking to the heatsink. I've seen one time big mosquito shorting two domains simply by being stuck in between the heatsinks of the two domains. I've seen like residues, weird residues going to the chip legs. There can be corrosion as well. So you want to look into the physical state of your hashboard before doing anything logic-wise. So we want to remove the more crap we can before doing our analysis. And we also want to do a visual inspection. Always remember to do a visual inspection of your hashboard, because if there's a short, again, you might catch it by eye and you might avoid creating more damage by doing your diagnostic with the power supply on. What I can see visually is that this chip here, it is a bit broken. So we have physical damage to this chip here. You can see there's a hole in there. Sometimes the signal is going to pass by. Let me show you. Sometimes the signal is going to be able to pass by. But really in the unit, this might be creating issues. This one here, it looks like it has damage, but it's not. It's just like a spot there, a missing thin spot, but it's all good. Oh, and you can see another thing interesting. You can see one of the famous solder balls we were talking about. So you can see here this thing here. This is a solder ball there. See, I have it on my tweezer. So you can see that the this chip there, it starts to delaminate. The tin has been pushed away on the sides, and sometimes when it's less fortunate, it goes on those sides of the chip, and it creates a short, and then the hashboard dies. All right. So everything else looks good. So I'll start by changing this chip without even doing a test on this board first, because we can see there's actual physical damage. And when we have physical damage, we want to take care of that before shooting power through the dashboard and creating more damage, right? Again, simple process. We use our flux, put flux on the chip legs on the top, on the bottom, take our tweezers, hot air station, and we start doing the work. Let me see while this eats if we have any question in the chat. And it looks like we don't. So not too many live viewers for the first streaming. that was expected. We didn't share it on the social networks yet. It's really more like a test for us. We can try and see what works, what doesn't, where we need to improve. We know we need a microscope for you guys to be able to see a bit more what we're actually doing on the screen. Um, I do like that setup. Either you look in live or you look offline. Well, actually, you look after the broadcast. Um, I would like to know if you like that configuration here. So we have, our back cam. I can also go into our back cam like that with our multimeter or no. So we can change the viewpoints that we have here for you to be able to in the best case, see what's happening. We have our chip map on the middle on the right side, and we have my face on the bottom right corner of the screen. Do let me know if that setup is making sense for you. Um, and we'll try to improve from your comments. We'll try to improve with, again, more capacity to zoom onto the actual work. So for now, you're looking a bit more distant on the screen, but it allows you to see still what's happening on this board while I work and while I explain it to you. And we'll get the microscope for next time. So I'm still eating a bit right now on my pad because there was some solder bumps on top of the pad. What I do is I use my tweezers and I just gently, very, very gently scratch the top of my pads to normalize that soldering. So we don't want any bumps when we're going to install a new chip. We want everything to be as flat as possible. Again, let me try to show you on the screen our pad here. You can see nice and clean, all shiny. Tin is looking good. Pad has no bumps on it. Everything is flat, so it should be ready to receive a chip. Just before, obviously, we'll be cleaning that pad with alcohol. I'll cool down the board again because we don't want the smaller components around the chip that I'm going to be installing and around the pad that I'm going to be cleaning to fly away when I start cleaning with my Q-tips. So let me give a bit of a cooling shot on the top as well. And I have one of my staff that's going now, so I'll just let him know that his work is appreciated. All right. So really, I'm the one doing the streams, but I'm not the expert here. We have a team of sorry about that. We have a team of about 30 repair technicians. They're the one doing wonders. They're the one mostly getting their hands on your hashboards. They're the one doing the upgrades. They're the one doing the diagnosis in the test room. They're doing it like I'm showing you now. So we have a very incredible team here, and they're much better at what I'm showing you right now than I am. I've been in the mining. I'm not a pro in electronics. I've been learning through my team here. I've been learning a lot, and it's a very exciting venture that we have here. So do know that we have a very big team of experts looking for you that are much better than I am. Um, this one chip here is looking great. We'll install this one. Flux on the center of the pad. install the chip. Again, do remember we have the chips available on our shop. You can go ahead. We have essentially every model you might need. We have all the models for the 17 series. We have for Ultra Plus, S9, 15th generation of Antminer as well. For Westminer, M20X, M30X. Uh, we have it for Silicon as well, T2T, T3, T3 Plus. Um, we also, in the Silicon family, we also do Hashboard upgrades for the Ethereum family. So the Silicon, what is it again? Uh, Silicon, I can't recall the unit name. Um, Heatmaster, yeah, that's it. So we upgrade the Heatmaster dashboards 4 to 5 gigs, 4 to 6 gigs, 5 to 6 gigs. So this gives your machine more running time and more efficiency because if you're not running at least 5 gigs at this date, you will be stuck on other alt coin chains. Um, in my mind, Ethereum is an altcoin by itself, and I won't dare too much mining with it. But there's a lot of people that find their cup of tea with Ethereum. That's their bet and that's their guess. In any case, we do upgrade those units for your convenience. Let's solder that chip. All right, install looks great. Let me bring back the camera here. We'll cool down the board. Now, at first sight, I do not see any more damage, um, physical damage at least, on this board. So we're going to be ready for a logical inspection of the dashboard. Go ahead and grab my smoothie there. Clean up the flux. Try to remove that flux bubble there as well. It's well stuck there. While we're at it, we'll try to remove all the dirt from there. dry this board, and we'll start our logical analysis of the board just after. Alright, that should be good for now. Plug our I/O cable, so our chip map is going to reset. Alright, power supply plugged in, we can power on. Let me have the multimeter on screen, and let's start the test. We're not going too far, so it seems like the issue is on the SIGINT domain. We'll be looking at chip number 7, which is this one here. Our chip map makes that very easy to locate. So let's go ahead. Again, we'll use our negative probe to ground ourselves on top of the chip to be grounded on that domain, and our positive probe to go and look at the signals of that chip. So I always start by looking at the clock signal because this is essentially the most important one that's coming out of the chip. So well, it always depends on the issue you're having, right? But when you're having that kind of issues there, you're going to be looking at the clock first because so the signal that's coming from the last chip, the 48 chip, the RI signal, RX signal, is going like that, like a snake through the board. When you have this signal, or let's let's go back. When you don't have this signal, you'll have most of the time you'll have a zero ASIC problem. Zero ASICs, they can be caused by many other things, but this is going to be one symptom that you're going to look for when you have zero ASIC. You're going to be looking for that signal, hunting for that signal. You're going to look at your power distribution as well, and many more things. But yeah, so when you have some ASICs, like in this case we have the 7th chip, we know that this is this is not the issue with the chips. Even the 7 chip there is having the correct value for the return signal because this signal is because it's passing by. We can locate the issue being on the 7 chip. Now, when I did measure the clock, I did see here that we have a weird value. So our clock doesn't seem too good. I don't believe the issue is with the resistance, but just before changing the chip, we can go and make sure of that. What we do is we stop the test. We can power off our power supply. We'll put our multimeter in resistance mode, so we'll be able to look here at the values, and we're looking for 33, so this is looking very good. If I stay on point, whoop, let me go back, and there we have it. So the resistance is good. It looks like the 7 chip is our issue. Let's go ahead and change that. We can shut down the multimeter. We can remove it from the screen as we don't need it anymore for the time being. Unplug everything. Always make sure that your power supply is powered off before doing anything like that. It's ideal to remove all the wires to avoid any mistakes while you're working on the board, because if you have power or your I/O cable that's plugged in and that there's any other component that's failing, it's possible that there's current flowing through and that you'll be creating more issues with this board. So do make sure it's unplugged and at the very least that it's powered off. Flux on top and bottom of the chip. At air station, we heat the chip, wait for the solder to melt, and we'll remove that chip from the board to replace it with a new chip. Again, make sure my pad is very flat. Make sure my tin is good looking color. Everything looks in place. I think I can use this pad as is. What I'll do is I'll cool down the board, cool down the pad, make sure it's all good. The surrounding components are in place. I'm going to be able to clean it with alcohol, and we'll put some flux, install the chip, and look at the board, see if there's any remaining issue in the circuit. Mm, Again, we can go a bit faster with our handheld fan. There's still some crap there. We hold the chip in place. Make sure there's the very least possible flux residues under the chip. So we keep a very small pressure on top of the chip. We don't want to break the chip by putting too much pressure. Really just hold it in place. Make sure nothing goes beneath it. Make sure that the connection to the pad is good. Make sure that the chip legs are, doing those little blobs, and that they stay intact. When you think it's all in place and that it won't move anymore, you can remove your tweezers, cool down the board, accelerate the cooling with the fan and L fan, and we'll clean a little bit of the flux residues with alcohol. It's actually, technically you won't be required to clean all the flux from this operation. Let me just bring this back. looks like decided to flip on us. Just a sec. Oh well. All right. Well, one thing that didn't catch my eye the first time, but it does. It seems like it's working, but it does disturb me a bit. The quartz there. Let me make sure. There you go. The quartz. It's a bit off, so I'll just gently bring it back um, to the left. Just make sure it's really well centered. It's actually working, and as long as the contacts are good, and I can see the contacts are good, but it does annoy me a bit. There you go. Anything that you see that is off, that's not the way it should, you want to eliminate that variable as a possible cause of issue on the hashboard. So I don't believe it was an issue there, but I want to clear that off my mind. If I have any issue on that board, I know it's not because the quartz was misplaced. Might be because the quartz isn't working, while I doubt it because we won't have any signal on the first chip. Well, in almost any case, it won't go through. I believe we did see one case where the signal was passing by and was the crystal that was the actual issue, but those are very rare. When the crystal isn't caused, normally you won't be getting a good clock out of your first chip to start with. So the arc tester is ready. We have our power supply that's powered on, 21 volt. Our chip is well set. Our crystal is well set. Everything should be cool by now. We'll start our test and see if our issue has evolved or if this board is fixed. And it looks like we don't have any signal at all now. Let's try to analyze what just happened there. So this can happen. Obviously, we want to fix the board, not make it worse, but sometimes it can happen. So let me start with the last domain here and look at the signal that's going back to the first chip. I'm looking, so grounding myself on top of a chip again, looking at the RI/RX signal, the one that's going back, so from the 48 chip to the first chip. And I'm going to be looking for values of 1.7 plus or minus zero point 0.1. So you're going to be looking for 1.6, 1.6, 1.7, and 1.8. So this here, it passes. We'll go, and what I do is I skip domains by domains. If my value isn't good, I'm going to look for the issue on that domain. And it looks like the issue is in between that domain. 1.8, let's look here. 1.8. Oh, looks like it got stuck at the chip that we replaced here. This one actually. If I measure 40 here, we're all good. So the return signal is going there, but when it leaves this chip to go to the other one, we have some issues. Really looking like the chip might be in cause there, which surprises me because really the installation is looking very neat. But it does happen. It does happen that you have some very good looking chip, good looking installation, but there's actually some default. So one thing that annoys me as well on this board, but the issue is there. So between here and here, but this chip just before the top here, the solders, they're very dirty. I don't know if you can see that properly, but what I'll do is I'll also clean that. I'll change the tip of my solder because right now it's a pretty heavy one. I'm gonna want to have a finer tip for that operation, something like this. I won't, lose any time. So what I'll do is I'll go ahead and clean those legs there, but I'll also remove the chip I've installed and reinstall it properly because it seems the issue might be there. Quick comparison, it looks like we're not sure if those resistance are, they look damaged. So there might be more than one cause there. Very gently, I come and I pass by, I let the flux do its job, so no need to go crazy about it. But we have to be very gentle, let the iron tip clean the pad there, clean the chip legs. Alright, alcohol will clean the area. lower my wind speed. Alright, pads are intact. So I'll go and extract some resistance from there, this donor board. So we're working with very small components there. Normally I would go and grab special glasses to be able to see through. I do think, yeah, I did lose one resistance there, so I'll go and grab another one. Alright, this one is going to sit well in place. There you go. So those two resistance back in place, and we remove that from the way. Alright, we'll reinstall the chip. The same one should do. There's nothing weird on that chip. All is good. Chip legs, pads, everything looking great. Mm, it's under my fans there. I wanted to grab my handheld fan to uh, accelerate the process of letting that chip sit down. Just wait a little bit more. It is looking great. All right. All right. Physical inspection is looking great. Let me bring that centered back on the screen. There you go. Let's take our handheld fan. Let's connect our tester so we'll have a clean chip map. Give the board a little bit more time to cool down. Let's reset our multimeter before it runs out. Let's take a sip of that smoothie. All right, we're good to go. It is still warm a bit. Let's still cool that down, but I think we're safe to start the test. Hmm, still zero ASIC. Let's see if the issue is at the same spot. Weird. So now that I came and mess here, it seems I can't go through that chip. All right. We'll have to look at the chip number 44. Oh, so I didn't realize this at first, but I was missing a capacitor here. Here? No, I just removed one because I was looking to clean the area. Realized there was also some bridge in the path there. So remove the bridge. We'll have to install new capacitors as well. It's possible that I did that in my previous manipulations. It's possible also that I didn't cut my eye at first sight and that it was missing from the get-go. I guess we'll have to go and rewind that stream to answer that. In any case, we're missing capacitors there, so we'll go ahead and fix that issue, reinstall a chip, and my bet is we should have something. It's really possible that I did create that issue as we did have our return signal at first, and that can happen from time to time. All right, capacitors in place. So again, quick visual inspection. Let me remove myself from the background while I look there so you can maybe say a bit more what's happening. So let me just see if anything else is missing there. From the looks of it, everything is there. All right. So we'll clean that pad and we'll reinstall a new chip. Ça mène à fond, CryptykHex. Donc, salut CryptykHex. Ben, présentement, ce board-là, en tous les cas, on pourrait dire qu'il mène pas vraiment à fond. Euh, mais on va s'arranger pour qu'il mène à fond après. enlever le multimètre temporairement du chemin pour une meilleure vision du hashboard. Alright. Bon. Donc, espérons que c'est la dernière fois qu'on a travaillé dans cette région-là, puis qu'ensuite, on aura un autre problème. So let's hope it's the last time we work in this area, and that we'll be either working on another problem after, or that this board is going to be fixed. This one should do. Read the chip, put in place. So I remove the chip because it's wiggling on the pad, so it makes me think the pad is not flat enough. This is an area that's giving us some trouble right now. What we can do as well is we can use one recycled chip. Sometimes those they sit in better. Try to show here what we'll be doing. So this there. Very gently we go on top of the pads. Try to remove the excess solder and normalize everything. Very gently on top and on bottom. That should do. Looking great. Have a closer look. Is there? Yeah. Let's remove that crap first. And put more flux. We'll use that recycled chip for this operation. Mm. All right. Hopefully this one is the one. One thing I often say is sometimes you have to take your time to save time. This is one of those cases where you must take your time. If you try to go too quick, you'll end up you taking more time to fix your mess. All right, so hashboard is plugged. We'll power on our power supply, 21 volts. Everything is in place. Board is cooling down still a bit, still a bit warm to the touch. We'll wait 1 more minute before launching the test. Pretty decent now. So let's go ahead and see. Let's go ahead and see what happens this time around. Launch test. Fingers crossed. Oh, we're still at 0 ASIC. That is a shame. Our issue is definitely here now. $33, and I believe if we compare, but this one should be at 33. Yeah. Yep. So that's not the one. Those guys look in value. Let's compare still with another domain. Domain. Yes. And yes. So capacitors are in place. Resistance is in place. Resistance values are good. Um, let's look at the diode. Yeah, this is off. Not by too much, but it's definitely off. Oh, this one is off too, though. Even this one is a bit off. 420 minus 20 can do it. So we'll allow it for now. The area is definitely a bit messy. Looks like this board was already worked on in the past. Let me just make sure again that everything is looking like it should. Remember, when in doubt, you compare with other boards. Well, it might do because those, if I want to show you here, we do have like very fat solders. Let me grab a tweezer to show you. Right there. Don't know if you can see it properly on the camera, but this, it has short, like fat uh, solderings. I'm not sure if like they're not creating any short that I'm not seeing. Still might be the chip that I've installed, but I'm starting to doubt that the issue is related to the chip because we've been working with this a bit for now. Saying bye to one of my good staff here that's leaving now. Let's fire on the iron. We'll just redo those pads. I'll clean those resistance. I'll use some resistance from our donor board. Some boards like this one, they can take more time. Some other boards like the first one, they can take almost 15 minutes all in all. So the average is about one hashboard per hour, I'd say, for the 17 series. Really depends. It depends on many factors. It depends on the chips. It depends on the batch you receive. It depends on how much you know that board. Um, some people are better on S17 plus, T17 plus, T17. Some people are better on S17. So it really depends. Don't be yourself too much. Every repairs is a different experience. Sometimes they're easy. Sometimes they're a bit more painful. So this is the area we're looking for. All right. Said I don't believe it's the chip, but still, it's trying to make sure it's well set in. So we'll test it. If this one doesn't cut it, um, maybe I'll just go and grab another board. We'll put this one on the side. Sometimes, it's helpful to, uh, you know, uh, move the problem, work on something else, come back to it later with a fresher mind. So 2 hours. The count so far is just one hashboard. That not so great. And we're still at 0 ASIC. That's annoying. Oh, but we did get past there. So we did fix this issue. Finally. Okay, are we passing here? And we are. Alright, so you know what? We'll keep working on this board because now we did fix this issue. So the issue lies somewhere else. Hopefully it's not the other chip that we installed there. Alright, so we're able to close the... Oh, you can't see the measurements. Let me fix that. There. So again, just to show you, we had this chip here. The return wasn't going through. Now we have it. 1.8. That's good. This chip we installed, 1.8. That's good. So if we go ahead and look at this domain, 1.8. We'll go to the next domain, 1.8. Next one, 1.7, essentially 1.8. That's good. Next, next, next. Something's weird there. Alright, so here it goes in full force. This one here, good. What's that? Can we have a measurement there? Looks like we might have the issue here. That's good. No good. If we look the one just after, 1.8. That's weird. Sometimes you just have difficulty to ground on top of those chips. Okay, so one more test we can do. Let me just identify this chip. When it's in the middle of the board, it's sometimes a bit harder to remember. So we'll put some orange there. This is the chip we want to look for. Bring the light back. We'll go into diode mode. I'm going to ground myself there. I'm going to go and look. My return is going there. Oh, we're pretty much in value. So diode mode test is passing. If we go on top of the chip though, we can't make a measurement. So it's possible that I'm just not able um, to ground properly on this chip for my tests, and that the signal isn't breaking. So we'll keep this chip in mind, but it's possible that it's not the one that's the issue there. So let's bring our power supply back online. The one just before, again, we had, sorry, need to reverse polarities there. We had 1.8. This one, we're not able to measure, so we can assume it might be dead. But the thing is, if we look at the chip just after, we do have a normal return signal. And the return, if it breaks there, we shouldn't be making a reading there. This one is good. Oh, and previously I believe it wasn't. Maybe it was a misreading. So let's keep going and see what happens. Okay, so far so good. Let's jump a domain. Good. Let's jump a domain. Oh, something's there. On the domain that we have installed the chip. So let's bring that board here. So again, go here. All is good. And we'll follow the traces from there. So that's good. That's good. That's good. No good. I believe I'm gonna want to go here. Uh, what is it? Yeah. What is coming hot? Let's just see. I think in continuity. So we did two things on this domain. We cleaned this chip and we installed this one. and I'm pretty sure it's going to be something related to one of those. We'll try to see if in diode mode we're able to spot something. So I ground myself on the board with the positive diode there. My power supply is turned off, test is off. Let me remove the wire there just to make sure. Let's remove those. Alright, so clock is a bit off on this chip, but let's ignore for now. Oops. Good. Meh. We'll tolerate for now, but let's remember. Um, I believe this one. Yeah, that would be the one. Let me just confirm with a neighbor domain, but yeah. So it looks like we have an issue out of this chip. Let me bring back the light. So see this chip, so the clock is going that way, and this trace there, that's the clock trace. So I can come and test against this resistance here, and we get 475. Now if we want to compare, so signal going that way, that way, that way, see this domain, it does the same thing from out of this chip to this resistance there, and you should see 1200 volts resistance, plus or minus 20 is the exact tolerance. Now we can have 1170 and that should do the trick, but this here definitely is no good. And if we look at the chip that precedes it, we're 1180, so we're essentially in target. So really it looks like this chip here is the one that's causing issues. And remember, again, I did mention that playing with glue not, is not such a good idea. That might be the case for what I was saying. So let's go ahead and change that chip. By the way, let's clean that pad. We'll redo the chip legs there with the iron. Now one thing I'll do also while we're here, lights on, and let's measure the resistance. All looking good there. Just before I went red. Yeah, looking good. Let's put this aside. Just want to flatten the pad a bit more. I can see a little bump. That's going to create some issues when we try to install the chip. All right. Let's go ahead and try to install a recycled chip. Just want to make sure everything is in order with this chip. Looking great. So set it in place like so. There you go. Start to eat. Change camera. Now, there's always a dilemma when you're working with boards. Like if you keep going on it, like if there's only one issue remaining, you might be coming to an end. But at the same time, if you want to try to keep an average of at least one hashboard an hour, the more and more you go deep into an hashboard, sometimes the more and more you get uh, off your goal. So it's really a dilemma. Sometimes it's harder to make the right call. And the best way, honestly, is to have a rotation, a board rotation. So now I'm doing the stream, but normally when I work, I try to have one, two, or three hashboard that I'm working on, and I do a rotation in between them. So while one cools down, I work on the other one, change chips, put it to cool, take the other board, keep resolving issues. Most of the times like that, there's going to be one hashboard that takes 10, 15 attempts, but at the same time, at least the other boards they have a rotation, and you normally you're able to pump one out every hour or so, even more sometimes. There are days you can have an average of 3 hashboards an hour. Some days you have only half that. Still zero chip. Let's go look at the power of this domain. Alright, so LDOs are working properly. So this domain is well fed. The issue really lies on some components in between those two chips. Bring back focus there. So the issue lies really in between here and here. There has to be either a chip or a component like a resistance or a capacitor that isn't working properly, and that's creating that drain. Um, we've changed the chip and we have the same value, so I don't believe the problem is going to be in the chip. I have looked at the resistance around. They look good. Whoop! I've lost my camera there. Let's come back to this one and see what's up. We're back. Alright, so this board for now, it looks like it's a time drain for me. Um, Again, can make another quick comparison, see if there's any missing component. Alright, so I'll put this board aside for now. It's a time drain for me. I want to make more hashboards. The more hashboards I make, the more I have happy customers. I'll be back. Alright, there we go. Oh, we can go back to this one here. Let me zoom back. There we go. Amazing. So again, we do a physical inspection of the board, make sure everything is to the eye in order. Plug this in. Power supply is powered off. We plug in alligator clips, power on the dashboard, sorry, the power supply, and then power on the dashboard through the ASIC tester. Oh, weird. This was in my non-working pile, so it might be temperature sensor related, this issue. Let's go ahead and call the temperature sensors. Signal wise, it looks like the chips are good, but sometimes the temperature sensor issues, they can be either related to the very temp sensor IC, but it can also be neighbor chips that aren't passing the correct values. They're good for the signal, but as soon as you call the temp sensors, they fail. We'll see. Looks like the current drawn from the dashboard is normal and steady for now, but I would expect the temp sensors to be showing by now, and they're not. Something is going on with this board. Still no temp sensor. What I'll do is I'll stop this test there. Stop it. We'll lower our voltage. Let's go to 17 volt and see if the issue can become more obvious to us. So start signal test again. We'll see if at 17 volts we can make it to the end. And we can. So this is looking great. Now let's call onto the temperature sensors. Again, current being drawn is looking normal and steady. Ah, there you have it. There had to be an issue. Alright, those are the fun ones. So for that kind of issue, normally we'll look for the BI signal. So when in advanced mode like this, calling onto the temperature sensors, we're unable to, well, to make it to the end. There's probably a BI problem. So let's go ahead and measure our BI. Let me put the multimeter on screen. And our BI signal should be this one. So measurement, this is normal. We should not be seeing nothing on the BI. If we see something, then there is an issue. Whoops, this one here. This one here. This one here. Okay, great. Yeah, there is some noise there. You can see some noise there. Doesn't seem to be the source there, so we'll keep on searching for it. That small bump is normal to 0.2. That's normal. So it looks like this chip is the issue there. Let me show you again. There. We always have a reading there. This is noise, not normal. So it looks like this this chip is the issue. Let's change that chip. Now, if you're watching in real time, it's now 9:30 p.m. Eastern Time. Uh, so the office is getting more and more empty. I'm now at 2 hours and 40 minutes ish of streaming. So I would really like to have at least 3 dashboards fixed by the end of the third hour. That's going to be a challenge, but it is possible. So let's try it and do that. Because otherwise, I'm going to have to stream for a 4 hour and get 4 dashboards. Because anything under one dashboard an hour in average is unacceptable to me. Alright, let's also give it a iron shot because it's irregular. Now this one I did realize there was some missing um, solder. So let me go ahead and fix that. Install the chip. It's gone. 90% of the problem on those dashboards are going to be chips. The other 10% is going to be uh, more painful to find. Normally, it's going to be capacitors, resistance. Those are very small components. You can miss them by the eye. Uh, there's a lot of those to measure also. So if you want to measure, normally you measure around the chip where the signal is stopping. Um, Obviously, there's also power failures. So there can be the LDOs. That's one of the components I've measured on the other dashboard. There can be the MOSFETs. There's going to be the boost. Um, in anything in between the PIC and the MOSFET as well can be causing issues. In this case, it really looks like it's a chip issue, like in almost any case. It's almost always chips. Alright, so since we've measured this issue at 17 volts, I'll stay at 17 volts. Power supply is powered off at the moment. I'll power it on in a moment. Um, we'll start the test again, signal only. Look if the signal is still being detected with this new chip on. If everything is looking good signal wise, we'll launch the temperature sensor um, test after. It does make sense that it was causing an issue because if you want to see, so this is our new chip we've just installed, and this here is a temperature sensor. So when we call the temperature sensor, because this chip had some inaccurate values, it might be infecting the reading from the temperature sensor, and then things escalate from there. The board doesn't answer anymore, nothing works. You put it in the unit, it gives you 0 ASIC. Or a temperature sensor issue, while most of the times it's not the actual temp sensor that's the actual temp sensor IC that's not working. Most of the times it's actually a neighbor chip that isn't working correctly. Let's prepare our multimeter for readings if we need to. This looks cool enough so we can start our test. Power supply is powered on at 17 volt. Why is my tester not starting? Ah, okay, there you go. So normal signal test. Signal is still passing by. So chip installation was done properly. Now let's see if this was the only issue on this board or if we have anything remaining. Temperature sensor test is on at 17 volt. And we'll see what's the reading. We have it. Board fixed. Before we call it any permanent victory, let's just bring our power supply to 21 volt and rerun that test again. But I believe this board is fixed. See, so most of the time when someone tells me my hashboard it doesn't work because of a temperature sensor, it's very quick to fix, na na na. Sometimes yes, as you can see, this board we didn't lose too much time on it. But when you have a lot of a lot of chips that are causing that issue around a temperature sensor, it's not always just a temperature sensor that you need to swap. Most of the time, it's not that component that I just showed you. So again, let's come and zoom. Most of the time, it isn't that temperature sensor IC that's the actual issue, but some chips around it, and you have to hunt for that issue. So 21 volt is on. Let's put on the light back on this multimeter. Start the test, normal signal test, and then we'll go and call the temperature sensors. If everything is good at 21 volt, we'll call it a victory on this board. Let's launch temperature sensor pulling. From the looks of it, current is stable. Looks like this is going to pass. And there we have it. So this board is fixed. Alright. So what's the count now? Let me see, what's the stream length at the moment? So we're at 247. If we're able to squeeze another victory in the next 13 minutes, we'll have our one hashboard an hour minimum average that I can tolerate. And I'll be able to call it a day because it's getting late. So let's see. Let me come back with another dashboard. All right, let's look at this one. So first, physical inspection. Might want to bring this here. Physical inspection. So there are, uh, how to say, there's that flux residue. My bet is when it's in the unit, those boards are actually sitting like that, and no, they're actually sitting like that, and the flux from the manufacturer, I would assume, just you know fell at the bottom of the board and it does that kind of residue. We do have, as you can see, the boards are very shiny. That's because we clean everything through the ultrasound. But this flux residue, it just won't go. You have to brush very hard to have it go away. And honestly, it doesn't do too much damage, and it's not time efficient at all to um, clean that. Alright, so power supply at 21 volt, everything is plugged in. We'll start by a normal chip test. We're at 0 ASIC, so we can't see, so let me bring back the multimeter, put light here. Alright, so this is good. This is good. 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 Looking good. 1.5 is low. Okay, let's identify this chip because it is a bit low, but we do have return signal on the following chip, so it might just be the ground that's not too good on the top of that previous chip. Sorry, wasn't going the right way here. My bad. But there is an issue there. I don't seem to have any reading here. Let's go to the next one. No reading. So something is breaking here. Um, Power looks well fed. Domains looks well fed. The issue is there, so it could be the chip, could be something in between. There is a lot of flux residue though in that spot, like heavy flux residue. Is it related? Sometimes it is. Sometimes it is. Let's make a comparison. Make sure we have all our components. Yeah. Let's go to diode. So everything is unplugged from the dashboard. Just ground to the dashboard. Look at the signal. It would be in range. It's borderline, but it would be in range. This is in range. This is borderline, but in range. But it's following this chip. Um, this is good. 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 So I would tend to think that this chip is faulty. The area is, um, I can't recall the word, but there's a, a good amount of residue there. What's the word I'm looking for? In French, we would say de la croûte, uh, but I can't recall in English. Let me look at one of my recycled chips. Looking good. So we'll use this for that case because I'm not certain the chip is the issue. So I don't want to start wasting new chips on this. New semiconductors lately with the inflation, the prices are crazy. So we want to make sure that it's actually needed when we change it, because otherwise we lose a lot of money. And we're not in business for losing money, right? Wait a bit still. I do recall the word I was looking for before. It's crust. There's a flux residue crust on the bottom of that hashboard. That's what I was looking for. And yeah, I do believe it's from the manufacturer default from manufacturing, and the flux falls down and cooks at the bottom of the hashboard. We see that on almost all the 17 series. Some more seriously than others, like this board has a crust. Some is just like stains. The stains normally they don't interfere, but the crust sometimes it does. So let's see if the chip was the issue. That might be it. But it might also be that we need to clean and clear that crust there, and that is a bit more of an annoying operation, as we might need to remove the components stuck in there, clean, and then reinstall. That can be time intensive. What must be done, but that's going to be a board for another day if this is the case, because I do need a better average, better early average than I have right now. How much time left for us to fix this board? Well, essentially we should have this hashboard fixed by now. So let's see if that did the trick. Hopefully it did, and we're on target. Otherwise, we'll see what we do. It's nearing 10 p.m. here, 10 p.m. Eastern. I've been at the office since 7:30 this morning. Oh wow, giving me that victory. Well, we do have issues remaining on the board, I believe, but looks like it wants to cooperate. We were at 0 ASIC, we got to 48. Now we do have some issues showing up here. So we change this one. It's possible we need to look at those chips. It's also possible it's because it's still warm to the touch. So pardon me. It's possible that that is simply the heat that still needs to leave the hashboard. But also, again, it is in the between that biggest stain of crust is in the between of where we're having issues show up on our chip map here. So it is very possible that it is related. We'll see. Still ish warm. Okay, let's launch this again and see. And now we're back at 0 ASIC. Oh, there we have it. 36, eh? Looks like this chip is having some issues. Now, is it the chip or is it the in-between? Is what we need to figure out. So, return is going through. Clock, I think, is not. Right? Let me make sure I'm doing this right. This here. Yeah, so that should be the one. And I don't have any measurements. Oh, even this one is weird. This is on value. This one is weird. But it might be because of this chip. And it's not giving any clock. Alright, well, it was a chip in this case, so we'll go ahead and assume it might be the chip for this one too. Still unsure. It wasn't a confluent diagnosis because, but again, I can't find anything else off right now apart from that flux crust. So we'll change the chip and we'll see. Not much people left at the office. I did hit a capacitor like a good noob. Let me put that back. Oh, it's getting hot. There you have it. Alright. It's all flat. We'll still do the legs for this pad because they're full of that flux crust. Keep this as clean as possible. While we're at it, I'll just clean the legs here that are full of flux too. Flux crust, trademark. There you have it. Flux, not crusted flux. And wait. Alright, we'll soon know if the, oh, that's no good. No good at all. So I was about to say that we we were just about to know if the issue was the chip, but now I just created more issues. That's annoying, but it happens. Fortunately, it looks like the only thing I smashed was the chip, so that's the only thing that actually moved, for what I see at least. So looks like our damage control is not gonna be too bad. Alright, go. Let's do this again properly. Still warm to the touch. We'll wait a bit more. Meanwhile, start the power supply, 21 volt. Tester is ready. Still up to the touch. Let's wait a bit more. Right. And let's launch the test. Let's say U hashboard. So it trips farther now. So now it looks like our remaining issues are here. So we did fix that here. Let's give it some rest. It is still a bit hot, so maybe just let it cool down a bit more. If anything, our issues are going to be here. We did change this chip and this chip, so let's go back. If anything, our issues detected are here, and we did change this and this. Now it looks like this is good. We can always compare with the multimeter, but from the point of view of the tester, this is fixed. Let's try again. This time the signal, oh, the signal still trips at 42. Let's go and make some measurements. Yeah, see, this one is too high. So there is still that one issue there, but I believe, apart if we have some nasty hidden issue, like a BI that's messing up with the temp sensors, this board should be fixed after this chip. And I'm pretty sure this one is a chip issue from what I see, but you know what? Let's just go and measure the resistance around it. Just eliminate that right away before we do anything. Come and grab it back. 32. Bit low, but probably just my placement. Don't think there's any issue there. Yeah, no, this is a chip. And this is why we cap our repairs at 5 components, because some of those boards, we change 4, 5, 6 chips, and they still have issues. Um, they're under a lot of stress, and as you can see, the delaminated issue is just crazy to deal with. That's why we do upgrades. Move that chip. Let's try to be a hero. Alright, and off we go. power supply at 21 volt. We've installed our new, well, pardon me, we've installed our recycled chip right here. So we'll make a new test as soon as it cools down. And hopefully after this we can call it a day. Not all streams are going to be that long. Some are going to be shorter. Some might be longer. I have no issues with doing long streams. We're just showing what we're doing. Essentially, it's the same. And we'll try to hit 2 hashboards an hour for the next stream because it is entirely possible. But it depends on if you're losing time on the same hashboard for a long time or no. I wish I was calling this board fixed, but it looks like 44th chip is giving us issues. It's in value though. Clock is in value. But it's back on 44. What's going on there? Clock is good. Maybe 45th chip clock is wrong? Oh yeah, this one is wrong. Okay. Okay, let's power off for a while. Shut this. We'll measure resistance around. This is good. This is good. 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 Distance is good. Can't see any missing component by the eye. So we have to assume, if the reading of this chip is wrong, that this chip is at cause. And so we go for 5th chip on this board. And there you have it. Truly hope this is the last one because it's normally the maximum amount of chips will be changing on a hashboard. Now, that is why we do use some recycled chips from time to time. Because we do know that some of those boards, they require more chips to be changed. And so sometimes we'll allow it if we're using recycled chips. So for this board, I've been using some recycled chips, so I would allow for more changes, uh, more than 5 chips. But I don't believe that's going to be the case. We should be able to make it with this. We'll see. There is a little thin blob on one of the chip legs. Just want to make sure I go and take the excess tin there. Okay, great. Right, let's hold this in place. Wait for it to solidify. And that should be it. It's a bit warm still to the touch, but let's see what the tester tells us. Getting to 47 now. Do you think it's gonna be playing us? Will we have to change the last or the chip just before the last chip? Or is it just tripping because of the warmth? What's you guys bet? Let's try to call the temp sensors and see. I think this board wants to mess with me, but we'll see. We'll see. Is it going to cut it or no? It is drawing a bit. Yeah, it is drawing some current there. Eh, yeah, looks like there might still be something weird on this board, and there we have it. Ah, annoying, right? Annoying. Alright, so uh, what do we do? I'll let the board cool down a bit. I'll put the power supply at 17 volt. We'll try to see if it's a BI issue or if it's related to that uh, chip we saw tripping at 40, well, either 47 or 48. Can be one of those two. For the clock, if it's the clock, otherwise it might be BI. If it's BI, we're gonna have a better chance to find it at 17 volt. Let's have the board cool down a bit more before running the test again. And visually everything looks great, even around the 47th and 48th chip. Let me bring on the light there. Let's look at the resistance around. Whoa, what's that? No, it's alright. False alarm. At this point, I wish it was just a resistance. 33. Let's try that again. 33 is all good. All good. All good. Can also look at our diode. Oops. Here we go. A bit off should do. Bit off should do. Bit off should do. And this one is always weird. This one here. Yeah. Alright. Looking more and more like the final issue is a BI issue. We'll see. So we have our multimeter at 17 volt. Board is cooled down. Let's launch signal test at 17 volt. We're getting to 48. 45th chip again, giving us some trouble. That's the one we just changed. Clock is good though. Let's look at the next one. Come back here. Clock is off on this one. The 46th. And we know it's not resistance because we've measured the whole domain resistance. So we know it's the chip now. Again. So the 6th chip we have to change on this board. That is very annoying. We didn't get the best boards to work on. At the same time, honestly, this is very frequent on the Hashboards that are queued for not for repairs but for upgrades. Those boards, well, normally when we queue them for upgrades, is because they have that kind of widespread delamination, and widespread delamination means those chips they've been cooked more, right? They've cooked in the unit while they were hashing or while they were rebooting, trying to start the hashboard, realizing that it was getting too hot and couldn't start. But some people, they reboot and reboot and reboot and reboot. They try to have their hashboard starting, and so the chips they heat and heat and heat and heat, and some of those chips, well, they give up or they have weird values like those one, and so we have to replace and replace and replace and replace. So truly this time, let's hope this is the last one. Let's hope. There is hope. There is hope. So again, a part of a microscope, which we obviously need for you guys to be able to see um, what I'm doing more clearly. Do let me know in the comments whatever you believe would make this stream better in the future. This is the first of many, hopefully. I plan to do one live stream like this at least once a week. This week I might be doing another one in 2 days. So now we're Wednesday. I might be doing another one on Friday. Might be about the same length at about the same time. Still thinking about that. It's the Grand Prix weekend here in Montreal, so it's a big weekend. Downtown is going to be very busy. Montreal is going to be very busy. gonna be very exciting. After all that COVID bullshit, it's gonna be great to have some life back. Um, I'll probably look at the practice on Friday. Look them on the TV I have installed here at the office. Um, I'm not going physically to the Grand Prix, not this year, but I'll be there in mind. So we might put the scoreboard of the Grand Prix in live while I stream. Maybe, maybe not. We'll see. In any case, maybe Friday we'll be doing another stream. It's probably going to be the same format with the same tools. So visibility is going to be what it is. Hopefully I get a microscope, not too expensive one, hopefully, since we're in the crypto winter at the time of making this video. But yeah, a microscope so we can have a better visibility of what I'm actually doing on the board there, and you don't have my head always on over what I'm actually doing, and I don't have to constantly go and look over it. Some streams, so yeah, one thing we did think about is some streams are going to be made by some other staff members of our team. So I'm probably going to be doing most of the streams. Um, but we do want to have more of our crew participating in that. Can do live streams of other activities as well. We do think live streams for repairs are nice because there's not too much content about ASIC repairs. It is one of our activities that did uh, grow very fast. We grew much faster at ASIC repairs than we did with ASIC mining. Obviously, in Quebec, with the moratorium and everything that's making it complicated for us to just run a business, it's been easier for us to work on making the repair center better, more efficient, um, make it stronger, make it known to the public. We have a lot of retail customers in Quebec. So even now with Bitcoin rate hovering around 20K, demand for repairs hasn't moved at all. Uh, so at least Quebec miners are very resilient and they aren't moved by the price action at the moment. At least we still haven't felt no difference so far. We'll see how it goes in the future. It is a very unfortunate thing that Quebecers were forced into a Celsius investment. So for those that don't know, Caisse de dépôt du placement du Québec invested in Celsius network here. I believe it's $150 million of the taxpayers, like savings that they've poured in there. Since then, I think the Celsius token fell for about 70 to 80%. So that was great investment, Caisse de dépôt du placement du Québec. Very great. Did a good job there. Also, like some of the funders, they're suspected by the SEC. I think so many like countries are reviewing Celsius and raising red flags. I mean, a lot of people in the industry, us included, are raising some flags and some question marks about this company, network, whatever it wants to call itself. We'll see how this all plays out. Getting to four. Ah, oh, come on. Hmm. Well, that might be it, guys. We'll see, but I might fix this tomorrow morning because now it's getting late and I have something else to do at the office before I leave. Oh wow, it's even worse now. It's even worse. And we're at 95 now. It's worse. It is hot, but I think there's still an issue on this board, to be honest. That's getting annoying. So look, what we'll do is we'll let the board cool down a bit more and do it one last test. And whatever the results is, I'm gonna end the stream because it's getting late. The dashboards we've worked on aren't the easiest one. They aren't the hardest one either. We've worked on way worse boards than those, especially the one with silicon. Those are a pain, massive pain. And honestly, anything that has silicon or glue now, you want us to fix it, it's going to be advanced repair price because it's just too much time. We're losing too much time on those kind of boards. Those boards delaminated, we get the hold of it, so they're not ideal, and there's a lot of components to change. But normally we're able to stay on target for about an dashboard an hour, and obviously there are some 17 series boards that we'll work on, and you'll see in future streams. We can do 2 or 3 of those every hour. So it really depends on the type of hashboard we're working on. It depends on the batch we've received. It depends on many things. It depends on the customers. It depends on the conditions the hashboard was, uh, the machine was hashing in. Depends on many things. Let's give it one last try. I just don't want to call anything anymore. We're at 17 volt now, so it generally there is more issues that show up at 17 volt than 21 when we just start the test. And if we can make it to the temp sensors that I just called now, and no, we don't. Let me just see. Yeah, so there's a BI issue on this board as well. BI is a bit like the reset. So when it breaks, normally the rest of the line is broken. So we should be seeing it um, everywhere. So this one here. Now if BI is here, it's moving here. The bumps are normal. They are a bit higher than I normally see though. But so far so good. But this one, it stays. There's always some noise on this chip. See, so this chip we might have to change. So this board is starting to be a mess of many chips to change. And yeah, let me just confirm that. Just a moment. This, so it means this one. Sorry, this one. This is normal. As I'm not seeing too much more noise there, I wouldn't say this one is necessarily bad. Might be. But we know there is a BI issue somewhere on this board. That is for sure. Okay, let's skip. Let's skip. Skip. So looks, was that a chip we changed? Yeah, I believe it was. Yes. Yes. This one, no. So this is not in cause. This one might be. If we go back here, this one, this one, this one. So see this one, we did identify it before as a potential issue. So yeah, there's still some stuff to fix on this board. Now I'm a bit tired, to be honest. I've been working for more than 12 hours today. So we'll call this a day. We'll call this a day for this streaming. We didn't make the goal for the stream, which is at least one hashboard an hour. But it is the first stream, so I'll allow it for this time. So I hope you did enjoy. Don't forget to subscribe, like, share on the social networks. You can visit our blog. There's a lot of content there. There's a lot of content on our YouTube page. We really try to produce a lot of content, a lot of variety of content. So there's questions as simple as what is Bitcoin that are being answered. There are questions more deepened into the environment, the environmental impact of Bitcoin. We're trying to look into Lightning Network, new technologies, second layer technologies on top of Bitcoin, and obviously, more importantly, anything attached and related to Bitcoin mining. Um, Go ahead and visit our service pages. We have hosting, consulting, repairs. We have mining brokerage. Uh, you can go and visit our partner, mobank.com. We also offer through them prestige hosting services. Through them, you have a minimum order quantity of 50 units. While with Decentral's hosting, there is no minimum amount, but do note that our hosting is currently full. And our repair center, right now, we're having a few open spots. So if you want to go ahead and send us some equipment, well, do write to us at support@decentral.tech. That is D-central, CENTRAL .tech, TECH, and please write and comment on the comment section so we can try to improve. Do let us know what you would like to see in the next streaming sessions, either be it related to repairs directly or to anything else Bitcoin mining related. So cheers.